In a previous video, I showed how the overrun works when the engine is in the idle condition. Now we're going to take a look at how the overrun works when the vehicle is moving. So this demonstration is using my D-Jetronic ECU tester, which allows bench testing of the ECUs. There's no actual vehicle in this test, and what we're doing is we're simulating the vehicle and its conditions. The first thing we're going to do is we're going to connect to the ECU tester, and we're going to set the vehicle to a 70 mile per hour cruise. Now we can see that this condition puts the engine speed at 3000 RPM and the throttle at 25%. Let's take a look at that on the chart. So we start recording data. We're going to look at pulse width of group 1, and we're going to look at the engine speed. And the engine speed, we're going to put that on the second y-axis. Okay, so here we can see that the pulse widths are 7.5 milliseconds, pretty consistent, and the engine speed is 3000 RPM. And I might just change that second axis color to better match the color of the line that it relates to. Okay, so we are going to tell the ECU that we've taken our foot off the accelerator. So over a period of 4 seconds in this particular test, we're going to lower the engine speed from 3000 RPM to a hot idle of 700. And for the throttle, we're going to remove our foot off the pedal, which will quickly release it. So when we execute this test, we're going to take a look at what happens to the fuel injection pulses. Okay, so we can see that the engine speed has dropped because we've taken our foot off the pedal. The throttle is at 0. The throttle dropped to 0 within half a second of the start of this test. And the fuel injectors were turned off, and then once the engine speed reached a low enough value, the fuel injectors were turned back on again. So we can see that as soon as the pedal is released, fuel injection stops. There's no point using fuel when you're decelerating. So now we're going to take a look at what happens if we slowly release the throttle pedal. So we're going to put the vehicle back into a 70 mile per hour cruise. So this is increasing the throttle back up, and increase the engine speed is back up to 3000 RPM. Now instead of removing our foot, we're going to decrease the throttle from 25% to 0 over the period of the 4 seconds. So this is a slow release. Okay, we see the same thing happens. As the throttle reduces and the engine speed reduces, there is a period where the fuel injection is disabled, but it is a lot smaller, a lot shorter than the previous period, because we're slowly easing off the throttle pedal. So what happens if we are driving along, cruising along at 70 miles per hour, and we want to slow down to maybe 50 miles an hour, so we're not going to completely release the pedal. So we'll put the car back into a 70 mile per hour cruise, and this time the engine speed maybe will reduce to 1300, let's say 1300, and the throttle pedal will go from 25% to 10%. So we're slowly backing off the pedal, and the engine is reducing in revs over 4 seconds. Let's see what happens. We can see there's a very, very small period now where the fuel injection is turned off. And let's do one more test. We put the car back to a 70 mile per hour cruise, and we will only ease off the pedal maybe 10%, and the vehicle is not going to slow down its engine speed is only going to reduce down to 2000 RPM. And in this case, there is no overrun condition achieved, and the fuel injection continues throughout the slow deceleration. So we can see that the overrun condition, where the fuel injector is turned off, only happens under rapid deceleration, where the throttle pedal is almost completely released and the engine speed drops down below the certain threshold.